All right, so the first thing to notice about this is that we are not plugging in a finite number. We have the limit as x goes to infinity. And so it's not just going to be a quick plug and chug infinity in there, because what we need to figure out is as x goes out to infinity. So think about the Cartesian coordinate system. As x goes out to infinity, who is going to dominate here? Is the numerator going to dominate the denominator? What is the final result going to be as we go out towards infinity? So the way that we answer that question is we put everybody on an even playing ground. And the way we do that is by first dividing by the highest power of the exponent that we have in the denominator. So we're going to divide by the highest power in the denominator. And the whole idea of that is that now everything will be a little bit more clear as far as who is going to dominate as we go out towards infinity. So in this case, the highest power is x to the first. So we are going to divide every single term of this expression by x to the first. So we divide each of these terms by x to the first, and we still have our limit as x goes to infinity. Now, once we do that, we then have to simplify. So we simplify, again, subtracting our exponents. In this case, the simplification involved is just going to be to cross out these x's, cross out these x's. And so when we do that, we are left with the limit as x goes to infinity of 5 minus 5 over x over 13. Now, we talked about in class that if you put in a really big number into the denominator, so if I have 5 over infinity, and you can think about like 5 over a million, what's going to happen there is you're not going to get another big number. When the big number is in the denominator, as you go out to infinity, this is going to approach 0. So what we do in the last step is we use the fact that the limit as x goes to infinity of a number over x to a power p, where p is a positive integer, is going to go to 0. So here what will happen, the 5 is going to stay as a constant 5. But this 5 over x, because the x is in the denominator, that is going to go to 0 as x goes to infinity. And then our 13 again is a constant. It will stay as a constant as x goes to infinity. So this will give us the limit as x goes to infinity of 5 over 13. Now, sometimes after you use this whole limit as x goes to infinity of this number and the denominator goes to 0, you still have an x left over. And if that happens, if there's still an x, then what you have to do is you will plug in the x going to infinity or the x going to negative infinity and determine the sign. So you'll plug in x going to infinity in this particular case to find the sign to see if it's going to a positive infinity or a negative infinity. But in this particular instance, you see that when you have the limit as x goes to infinity of 5/3, x is not left over, you just have a constant, so that means that your limit will be 5 over 13. I misspoke there, I said 5/3, but it's 5 over 13. So that is our limit.